Hello everyone. In this video we are going to use blockMesh to generate backward facing step inside OpenFOAM to run simulations. So we are not going to use any other software, it will be just blockMesh and create good quality mesh to run simulations. First I am in my run directory where I have the tutorials folder. Here we are going to make a new directory for this case called backward. You can name it whatever you want. So I will just enter backward here. Okay, now make sure that this folder is empty. Now I am going to open explorer.exe space dot. Do not miss that dot. Okay, so this will open this empty directory. Now what we are going to do is we are going to copy an icofoam case. So the location will be, once you enter the tutorials, we will be having all of these. In incompressible you will have icofoam, inside that you will have cavity, inside that again you will have a cavity. So you just copy all these three folders, 0, constant and system, and go back to your backward folder and paste it here. Okay, so when you go to your terminal and type ls, now you can see 0, constant and system, right? Okay, now this case is going to act as a template for us so that we can build our case on this. This is entirely different case, which is a cavity case, but we are just going to use the template so that we can build our case here. Okay, this case already has a blockmesh file, blockmesh dig file. So I'm going to run blockmesh. It is successfully generated. Now to view that, you will type touch space para.foam or case.foam, it doesn't matter, something .foam. Okay, now when I go here, I can find this file. So generally when you want to open a case in paraview, you type parafoam, like parafoam. If you are on Ubuntu, this will work, but if you are on WSL, this will not work, since WSL does not get access to the GPU nodes from the computer. We need the GPU nodes so that the visuals are proper in the post processing. So we are not going to use this. Instead, you just create a new paraview file using touch para.foam. But to open that, you actually need paraview installed in your C drive. So if you do not have paraview already installed, what you can do is you can go to Google and you can type paraview download. Inside download paraview, you can download any of this, either the first one or the third one. It doesn't matter, just make sure you are downloading the Windows version if you are on Windows. If it is Linux machine, then paraview directly comes with the installation of OpenFOAM and you can use parafoam command. Okay, now how to open this? When I double click this, it will not show paraview, so you have to choose an app on your PC. It will go to the C drive inside program files where I'll have paraview. Here I will go inside bin, and under bin I will find paraview.exe. Select that and click open. Make sure that you are giving it always so that it is very easy every time. Okay, now for the first time alone it will take a bit of time before loading it in paraview. Afterwards it will be quite fast. Okay, now we got the paraview file. I will click on apply and see what is the mesh which is already there. Okay, yes, now this is the mesh we have, and the boundary conditions are fixed walls, front and back, and moving wall, where the moving wall is top, fixed walls are these three, and front and back. So this is a generalized cavity case which we are not interested in. We are going to modify this blockmesh file so that we can get our backward facing step. So what is the geometry that we are going to work with? So this is a simple representation of what we are going to achieve. So this is a backward facing step. So we are going to separate it into three main blocks, which is this which is the green color, and then the red color. So we are going to generate three blocks and then make mesh to make it into a single mesh file or single geometry. So these are in meters, actually 2 meters, 3, 8 and 1.5 meters. So we are going to follow this. So before following this, let's see what is there in the blockmesh file. Now we don't need the paraview file now. Okay, And before proceeding, you can delete or keep this file, it doesn't matter to us as of now. So I'll just enter blockmesh dit and open it with either Notepad or Visual Studio Code, which one is comfortable for you. I personally prefer VS Code, so I'm opening it with it. Okay, now in the block mesh, make sure you are changing the scale to 1. By default, it will be 0.1. And whenever you are making any change, make sure to go to File and save it, or simply Ctrl+S, so you don't lose track of it. Before changing anything at all, let's comment this boundary entirely, because initially we don't want to name any of the faces. We just want to see how to generate the mesh. Okay, now this is the default vertices which is there. We are not interested in these as well, so I will remove everything except for say 0 0 0. That will be our initial point, and we don't want these two, we don't want this two. Okay, okay, now we are going to see how we are going to name the vertices. Okay, when we are coming here, let us assume a convention on how we are going to proceed. I am going to keep this as 0, this will be 1, this will be 2, this will be 3. So since we already named the black box, now we have to name the green box, but this point is already 1, so we don't want to name it again. So I'm going to name this 4, this will be 5. Similarly for the red box, this will be 7 and this will be 8. Sorry, this will be 6 and this will be 7. This is something I am very comfortable with. If you want to name it in a different order, it's up to you. Okay, so here I am representing only the front face or the back face here. So we will be projecting this to create 3D, since OpenFOAM cannot handle 2D directly. Okay, now this will be 0 comma 0 comma 0 for our reference. This will be 0 0 0. So based on the dimensions here, we are going to make the vertices on all of these inside blockmesh. Okay, now we have the 0 0 0, which will be the 0th vertex. Now let's go to the second point, that is first here. So it is point 1. So point 1 moves, okay, before that I will name it like this. This is x direction, this is y direction. In the x direction, x is growing 3 units. Okay, so since x is growing 3 units, here I will make x as 3, but y and z will be same as the first point, since it is not changing, and this will be our first point. To make the second point, it is also 3 in x but 2 in y. Okay, so I am going to make it like 3 2 and z is going to be 0 as usual. This will be our second point. So similarly for the third point, again x is 0 but y is 2. Okay, so x will be 0 but y is 2 and z will be 0. Needless to say, that is the third point. Okay, now let's come to the fourth point. Okay, on the fourth point, if you see, it is 3 plus 8 on the x-axis, which is 11. So 11 on the x-axis but 0 on the y-axis and 0 on the z-axis. This will be our fourth point. If you come to the fifth point, it is again 11 in the x but 2 in the y, right? So 11 2 0 conventionally. This will be 5. Coming to the sixth point, you can see that on the x-axis it is 3 and on the y-axis it is minus 1.5. Okay, so on the x-axis it is 3 and the y-axis it is minus 1.5. Z-axis is 0 obviously. This will be 0.6 and 0.7 will be, the x-axis is 11, y-axis is minus 1.5. X-axis is 11, y-axis is minus 1.5, z-axis will be 0 and this will be 0.7. we only have 7 points in the back face. Now we are going to project this uh, the front, something like this. If we have a block like this, we are going to um, sorry, make something like this. Okay, now the back face is what we made, the face here. Now we want to make this one. Okay, so this is our 0th point, and this is our 3rd point, this is our 5th point for reference. So when we are making exact copy of these, but just in increment of z-axis, we're just going to increase the value of z-axis and create new vertex some distance from the backplane. Okay, so I will exactly copy all of these and paste it here. So in the z-axis I'm just going to increase it like 0.1, so I'll change every z to 0.1. Okay, now this will be acting as our front face, if you can imagine. Now conventionally this will be 8, this will be 9, this will be 10, and so on. So if you can notice, for every corresponding point, the other is exactly some the value plus 8. For example, this point 000 and 000.1 lie on the same plane of the z-axis, right? So it is just, the index is just increased by 8. If it is 0, this is 8. For say like this is 0, this is 8, it is on the same line. So if you want to find the corresponding index, you just add 8 to it. For say if you want to find the corresponding point here for 5, just add 8 to 5, which will be 13. So that is what we are going to achieve here. Okay, now we will jump into making the block mesh. First we have to make the hex here. Okay, the hex will be like boxes which we are going to make. The first box will be made, let us take something like this so I can demonstrate it to you. There is a convention to be followed. Okay, so this will be our 0, 1, 2 and 3. So correspondingly this will be 4, I mean not 4, this will be 8, 9, 10 and 11. You can see 0 plus 8 is 8, 3 plus 8 is 11, 2 plus 8 is 10, 1 plus 8 is 9. So correspondingly we will be having something like this, and this is this box actually. Okay, now we are going to make this box alone. To make that, you have to take convention in anti-clockwise. Okay, so the first hex will proceed like this: 0, 1, 2, 3, like 0, 1, 2, 3, and then it will be 8, 9, 10, 11, the corresponding points: 8, 9, 10 and 11. And for simplicity I'll just keep 111 here. It is the number of divisions you need in each direction. For now I'll just keep it as such, and I'll go here and run blockMesh again. So it is running without any error, but we want to view it. Okay, now I'll go here and open the paraview file so that we can actually view what we have just created. We have a box here. Okay, yes, this is what we actually wanted. And if you go here and create a data access grid, you can see that this is 0, this is 2 in length, and this is 3 in length. So this is exactly what we wanted. This is 2, this is 3, so that is exactly what we wanted and we got it. And this is 0 comma 0 comma 0, obviously. Okay, now this is the first block. Now we can similarly create other 3 blocks as well and view it here. So initially you can see it is just single surface. We will subdivide it later. Now we are only interested in making next block. I will copy this exact thing here, paste it, and we do not want this. We are going to aim different box. Right, now here instead of these we are going to have other set of points, like this will be say 1. We are generating this box now. Okay, this will be 1, this will be 4, this will be 5, and this will be 2. So correspondingly this will be 9, this will be 12, uh, this will be 13, this will be 10. Okay, so we are going to do like 1 4 5 2 9 12 13 11. So it is 1 4 5 2, and then we have 9 12 13 11. 9 12 13 11, or sorry, it is 10 13 10. Okay, now I will save this file, go to terminal, run blockmesh. Now still no error. I'll go here and refresh it and try to move something, and you can see that we also got this block. Okay, and you can ensure that this is 11. So from 3 to 11 it is 8. That is what we wanted, and we got the mesh, I mean the geometry. We still have not generated the proper mesh. Now we have to make this block, the third block. So to do that, again we will do the naming. This will be 1, this will be 6, this will be 7, this will be 4, and correspondingly this will be 9, this will be 14, this will be 15, and this will be 12. Okay, so it's 6 7 4 1. Copy, paste. It is 6 7 4 1, 14 15 12 9. 14 15 12 and 9. When you are making something like this, make sure that you are always starting from the left bottom corner and then go anti-clockwise. You just keep following that, so it is very convenient. You don't want to do something like 4 1 6 7 or 1 6 7 4. Just keep it like 6 7 4 1, so that the convention is always kept properly, you don't get confused. I will save this and run it and hopefully get no error. Yes, we don't have any error. I will go here and refresh it, and yes, we have got it. Like the y-axis is 1.5 and the x-axis we got 11 in total, and this is exactly what we wanted and we got it right. Okay, now I will turn off the data access grid, and before that, just in case if you want to change this 8 to 10, what will you do? You just go here, change nothing except this one. Like initially 3 plus 8 was 11. If you want to change it as 10, now say let me actually change it. Instead of 8, we are going to have it 10. What we have to do, you just have to change it to 13, because 3 plus 10 is 13. On the x-axis we are increasing by 13, so just change these 6 values and everything else remains the same. You are just changing the vertex point. Save the file, run blockmesh, go here, refresh, and see it has increased. If you want to ensure, you can go to data access grid and see it is actually 13. So it is like 0 to 3 to 13, it is 10. Right, we got what we wanted. Now we are going to subdivide this. So if you see here, we have like 2 units and 3 units here. If we subdivide each unit into 10, how many will we have on the x-axis? On the x-axis we will have like 10 lines, right? So initially we will do like 10 10, and we will just keep everything 10 as of now to just have a base mesh and work on it. I'm not discretizing Z because we just want one unit in that, so we can implement the front and back end there. So I'll save the file, run blockmesh, go here, refresh. Okay, now you can see like we got 10 here, 10 10, and then we have 10 here as well. Now what I'm going to do is I'm going to subdivide the x-axis of first block alone into 30. Okay, the first block alone it takes 30. You will see why. So you see, like we got 30 lines here because it is 3 in length, and for each unit I am dividing the each unit into 10 parts. So that is 30. But what am I supposed to do here? It should be 20, right? Because it is 2 unit. So I will go here, y-axis it will be 20, but similarly, since this mesh has to be attached to this as well, have to change this 2 into 20. So I will change for second block also into 20. I'll save it. Before that, we know that this is 10, right? This unit is 10, so this will be 100 if I subdivide everything into 10. I'll save that. But we also know that this is also 10, I mean this length, so this has to be divided into 100 as well. But we also know that this depth is 1.5, so when I divide each into 10, we will have around 15. Yes, 15. So instead of 10, I am going to have 15. Save the file, go here, run blockMesh, go to paraview, refresh. Now you can see that this is a very uniform hexahedral mesh, like everything is a clean square here. Okay, but do we actually need this? Yes, if you just need this, you can proceed and run the case after setting the boundaries, but I'm not going to settle with this. I'm going to do something called refinement. I'm going to refine the mesh, how it is produced. So I'm going to subdivide everything further down. Like I'm going to subdivide each mesh into 2. So I'm just going to multiply everything by 2. This will be 60, this will be 40, so this will be 40, this will be 200, this will be 200, this will be 30. I'll save this, run the block mesh, and go here, refresh, change something. Yes, we got a very refined mesh now. But if you go to Google and say you search like the default pitch daily mesh, so pitch daily is a default tutorial which has a similar uh, structure. I mean, it is also a backward phase, but the geometry is not the same. So you can go over here and see how the mesh actually is produced. Yes, we have the mesh here. You can see that there is mesh refinement over the flow separation region. So we can achieve that by using something called simple grading. So where is simple grading? Inside the block mesh, you have simple grading here. So this is X, Y and Z as well. But how do we know which parameter does what? By changing it and running it, we can identify. On the X axis of the first block, for say I'm going to change this to 0.1 instead of 1, and I'm going to run it and see what changes. So here if you see, there is a gradient towards the right hand side. Everything over here is 10 times denser than here because I have given 0.1 in the x direction. So it starts rarer, and as it goes towards the right it is denser. But if I don't need like this much density, what should I do? I'm just going to change the value. In the block mesh, I'm going to change from 0.1 to 0.25 say, and I will try what is there. So the number of elements in that direction is going to remain the same. It is not going to change. Only how the gradient is generated is going to change. So yes, now we have got a gradient over here. But for say you want to generate gradient for the second block as well, but it should be around here, right, instead of on the right. So what you should do is you are going to still give 0.25 but in the negative direction, so it will be generated on the opposite side. Let us see whether it is working. No, it is actually throwing some error. Okay, it is saying some inconsistent grading because the grading also affects the third block, so we have to change the third block as well. I'm going to change it to 0.25. Okay, now it is not throwing an error. Okay, now if you see, we have got some denser mesh over here and rarer mesh on the sides where the flow is not affected much, This is very similar to what is done in the default tutorial, but we can also observe that there is denser mesh over here. So what am I going to do? I'm going to grading the y direction towards this side. So this is positive y, I mean this is how the y-axis grows. So if you are not very sure about how it actually goes, you just type in a value and then you can change the positive or negative. So for the y, the first block I'm going to do something like 0.1. Here it will be 0.12 because it affects the second block. And I'm going to save the file, run blockMesh and run it. As you can see, it is not what we wanted. We wanted the density over here. So it is very simple. Just change it to negative and the direction changes. Nothing fancy. Yes, now we got it. But we don't want this much density, do we? No, right? So we are again going to change the value. So it is just an iterative process till you achieve a decent clean mesh. But here we want positive 0.25 because it goes this way. We want the density here, not here. So I'm changing the third block as well and save the file and run blockMesh. And yes, we got something close to what we actually needed. If you still need more refinement, you are much free to do what you need. Even if you want to create like more cells in the y-axis of this third block, since there is a flow separation and flow attachment happening here, you can generate more cells over here. That is not a problem. Let me do it. In the y-axis, I'm going to, like, instead of 30, let me have 40 and run the block mesh again and see how it works. As we are having more density, more number of cells. So this is something which is much better than what we had initially with simple grading and all. If you still want to do refinement, it is up to your creativity and up to your physics problem, but this tutorial is just to teach you how to do these things. Okay, now we have created the mesh, but if you see, every patch is a default face now. It doesn't have a name. Without a name, we can't really run a simulation using the boundary condition files. We need the inlet, outlet, walls and everything. So we are going to do the exact same thing now. Okay, now I will go to here and I will uncomment this. Okay, now let us create what all we actually need. Okay, we don't need like moving wall, so I'll change this to inlet and the type is not wall. Inlet is a patch. We don't need this. I'll remove. Similar to inlet, we also need like the outlet, which is also a patch. Fixed walls, let this be fixed walls, but we don't need this. We will do the values for the front and back as well. We don't need the values, but let this be the same. So these are the four things which we are going to generate, but one by one, not at once, so that if we make any error in any one phase, we do not have to worry about on which phase we made an error. If we do one by one, we will know which phase we made an error and sort it immediately. So this is our inlet patch. If you can recall from here, so this works something like 0, 8, or yes, I'm going to like do this again so that it is very clear for you. This is 0, 1, 2 and 3. Similarly, this will be like 8, this will be 9, 10 and 11. Okay, so this phase is what we call as the inlet. So conventionally it is 0, 8, 11 and 3, right? If we go by anti-clockwise. So we are going to try that. So this is the phase we want. So the numbering is 0, 8, 11 and 3. I'm going here. I'll type 0, 8, 11 and 3. Save this. Run the block mesh and see if there is any error. No. We have two patches now. One is inlet. The other is everything else is default phases. You can go to para view, refresh, and you can see inlet just appeared here. Deselect internal mesh, select inlet, click on that. Yes, we have the inlet phase exactly how we wanted. Okay, now we will do the outlet. because that is what we want next. If you see, outlet has two phases here, so it is 5, 4 and 7. Now since we know the convention, it will be something like, if this is 5, this is 4, so this will be 13, add 8 to it, this will be 12. So the convention is something like 4, 12, 13, 5. I'll go to the block mesh, I'll uncomment this, comment this. So as we saw, the first phase, this outlet is 5, 4, 12, 13. 5, 4, 12 and 13. Make sure it is cyclic and make sure it is not throwing an error. Yes, it is not throwing an error. Go refresh here, select outlet. Yes, we have the top outlet. Similarly, we can do the bottom outlet as well. So it will be 4, 7 and corresponding to 7 it will be 15. Corresponding to 4 it will be 12. So it is 4, 7, 15, 12. 4, 7, 15 and 12. If you still have doubts, you can draw that and see how the numbering came. It is not a problem. Go here and refresh. Now you can see that we have a big patch for outlet, and that is exactly what we wanted. Yeah, we have a big patch for outlet. Okay, now inlet and outlet is done. Now we will generate the fixed walls before we do anything else. Okay, I'll uncomment fixed walls and comment front and back. For fixed walls, we have a lot of walls actually. The first wall will come over here. So this is the first wall, this is second, this is third, fourth, and we have the fifth. So we are going to make it one by one without any hurry. Okay, now we have, this is 3 and 2. So we will type 3 and 2, and then it goes something like this: 3, 2, and out of the plane it will be corresponding to 2. So it is 10. Corresponding to 3 it will be 11. So save it. If you are very unsure, run it and see every time. Not at all a problem. It is much better than running the case with errors. Okay, now we have the first fixed wall. The second fixed wall is this, so it is 2, 5. Yeah, so it is 2, 5, and corresponding to 5 is 13, and corresponding to 2 it is 10. Okay, I will run it, check it. You don't actually have to check it every time. I'm just doing this so that you will understand what we are actually doing. If you are very sure about your numbering, you can just proceed with all 5 phases without checking it every time. Okay, now we will do the third phase, which is this 0, 1, 0, 1, and corresponding to 1 it will be 9, and corresponding to 0 it will be 8. Okay, the next, okay, well, again run this, no problem at all. We got this. Now we have to do the vertical phase, right? Yes. So for the vertical phase, we have 1, 6, 1, 6, and corresponding to 6 it is 14, and corresponding to 1 it is 9. And now we will also do the bottom phase. It is 6, 7. So 6, 7, corresponding to 7 it is 15. 6 it is 14. Save it. Now we have got all 5 fixed walls. Run block mesh, no errors. Refresh it. Yes, we got all 5 fixed walls. We just want to see the fixed walls. These are the fixed walls: 1, 2, 3, 4 and 5. Now we are going to generate the front and back. So if you see, the back has 3 faces and the front has 3 faces. So we will proceed one by one. Totally we have like 6 faces. Okay, 0, 1, 2 and 3, obviously, because we have like this one, 0, 1, 2 and 3. Next comes like 0, 4, 5, sorry, 1, 4, 5, 2. 1, 4, 5 and 2. The next will be 6, 7, 4, 1. 6, 7, 4, 1. We have generated the back face. I'll select front and back, apply. Yes, we have got the back face. I'll also keep the fixed walls just in case. Okay, now you can see that that is the back wall. Similarly, we are going to generate the front wall, and it is nothing difficult. We are just going to add 8 to every point here and make corresponding points like 8, 9, 10, 11. I'm just adding 8 to every point in each of these. So here it will be 9, 12, 13 and 10. So for 6 it will be 14, 15, 12 and 9. Hopefully I did not make any mistake. Yes, I did not. I can go and refresh it here. Still it has, yes, it has appeared. So you can see that we have two front and back walls. It is empty, you can see in here. Yes. Okay, now we have the front and back, we have the inlet, now we have the outlet, and we have the fixed walls. Now if you just want to see the wall patch, you can select walls and see these as the group wall. Okay, now this is the internal mesh. We have generated exactly what we wanted. If you want to go for much refinement or much grading to generate gradients, it is up to you. So we have created the mesh. Now still we are seeing the default faces here. We don't want that, but you can select that and see that we don't have any default faces. We are not left with any face that is not named. You have to ensure that. Okay, now I can close this and open the paraview file again. Now you can see that we have created the geometry properly. We have the mesh proper. If you want to see in wireframe, it is, yes, everything is properly done. So that's it about this video. I hope you learned how to make backward facing step in just blockMesh along with the grading and everything. So if you like this video, consider subscribing to the channel and dropping a like to this video. If you have any suggestions or comments, please drop it in the comment section. I have given the paraview download link in the description, so check it out. Until next video, thank you.